I am Shuntaro Kato. I would like to talk about my research. Silent speech recognition (SSR) is a technology for understanding the content of speech without using normal speech. This technology is expected to be a method to support speech recognition. However, the current SSR has a problem of requiring special equipment and training. Therefore, we conducted our research with the following goals in mind. It is the ability to do SSR without restriction and without straining the body. The final goal is to develop an application that can easily perform SSR in any environment. A new SSR method is proposed in which an external noise is generated and the sound reverberated in the oral cavity is recorded, and classification is performed by extracting features from the recording using a spectrogram. The system consists of one noise source and one microphone. Figure 1 shows the processing flow of the proposal method, and Figure 2 shows the system flow. First, the noise is emitted and reflected in the mouth. Then the noise is mixed with other noises and recorded with a microphone. Then a spectrogram is created to extract features from the noise. Finally, SSR is performed using DNA to classify the spectrogram. Convolutional neural network (CNN) is used for DNA. In order to verify the effectiveness of the proposed method, we conducted 3 experiments on machine learning using spectrograms. In the experiment, the vowels of Japanese A, I, U, E, and O were compared and classified. Table 1 shows the experimental conditions. Under the experimental conditions shown in the figure, the noise source was placed about 20 cm in front of the oral cavity, and the microphone was placed about 5 cm in front of the oral cavity, and the noise was recorded for 2 seconds. Table 2 shows the training conditions. 4,000 speech sounds were produced, and the CNN was trained 200 times. First, I will explain experiment 1. Create a spectrogram of up to 10 kHz bandwidth from each 4,000 recorded voices. As shown in Table 2, the spectrograms are divided into training data and validation data in the rate of 8 to 2 to create dataset 1. After that, we train it with CNN. The training process is shown in Figure 3. Next, I will explain experiment 2. When we create spectrograms in experiment 1, we create a voice in which a part of the spectrogram of the voice is replaced by white noise. The spectrograms before and after the replacement are shown in Figure 4. Dataset 2.1 is created with the 3 different interval lengths of 20 milliseconds for the noise to be replaced. Dataset 2.2 consists of 3 sets of 20 milliseconds, 30 milliseconds, and 40 milliseconds. Then training is performed in the same way as in experiment 1. The combined result of experiment 1 and experiment 2 are shown in table 3. Finally, I will explain experiment 3. The input noise was changed from white noise to air conditioning noise. Under these conditions, we recorded the same way as in experiment 1. Then the noise was added in the same way as in dataset 2.1 of experiment 2. And training was performed. The results of the training are shown in table 4. Finally, here is the conclusion. We propose a new SSR method using spectrograms of oral reflection sounds. The result of 3 experiments shows the potential of the proposed method. In the future, we plan to examine whether the proposed method is effective the consonant identification and for identification in other noisy environment. This is all my presentation. Thank you very much.